Good morning, students. Students, this lesson is of class 9th for the subject of physics, chapter 8, propagation of sound waves of your textbook titled Concise Physics by Selena Publications and is given on page number 173. This lesson is submitted to you on 5th April 2021. Students, if you concentrate on your surroundings, you will be able to hear many sounds like chirping of birds, blowing of horns, barking of dogs, etc. And as we have already studied about sound in class 7th, that sound is a form of energy that produces the sensation of hearing in our ears. And it is produced when a body vibrates. So what is sound? Sound is a form of energy that produces the sensation of hearing in our ears, and it is produced when a body vibrates. Now, for example, when we pluck a string of guitar, it produces sound because of the vibrations produced in it when it is plucked. Now, students, let us have a look here. See, if a person vibrates the guitar. Now, can you see the vibration here? So, students, you can hear the sound when the string vibrates. See and listen in front of you. Now, coming to the second example, when we beat a drum, its membrane vibrates, which further produces sound, and when the membrane stops vibrating, no sound is heard. So let us have an example of a drum. Now students, see what happens when the drum is beaten. Just have a look and hear the sound and see the vibration of the membrane of the drum. The upper part which is being beaten is known as membrane. So just have a look. See what is happening here? See the vibration? What do you observe? So when this drum was beaten, the membrane was vibrating, and because of that vibration, we were able to hear the sound. And similarly, on blowing a whistle, the air in whistle starts vibrating, and thus a sound is heard. So what can we conclude from the examples? So the conclusion is a vibrating body is a source of sound. A vibrating body is a source of sound. And thus, sound is a form of energy. Mechanical energy is required to start vibrations in a body producing sound. And sound needs a medium to propagate from one point to another. Thus, these waves, after propagating through a medium, reaches our ears and produce vibrations in the eardrum, which are perceived as sound by us. So what happens here? Sound needs a medium to propagate from one point to another. These waves, after propagating through a medium, reaches our ears and produce vibrations in the eardrum, which are perceived as sound by us. And sound needs a medium to travel. That is, it cannot travel through vacuum. This is the reason why we cannot hear sound in moon or in space, as there is no medium on the moon for sound to travel. Now, students, coming to requisites of the medium. We know that sound needs a medium, but that medium should possess certain properties. So the three important properties for the medium are, firstly, the medium must be elastic so that its particles may come back to their initial positions after displacement on either side. That is, the particles are capable of vibrating about their mean positions. So the medium should be elastic such that the vibrating particle can return back to its initial position. Secondly, the medium must have inertia so that its particle may store the mechanical energy. And thirdly, the medium should be frictionless so that there is no loss of energy in propagation of sound through it. Students, now you can see a speaker in front of you. A speaker is used to produce sound waves. Now this speaker is producing sound waves. Children, see the air particles. These circles are the particles of the vibrating medium, and the medium surrounding is air. Now children, these particles, they don't start moving on the right side. Rather, they start oscillating about their mean position. What I want to say is, this is the way the particle is oscillating forth, backward and forth. But they are not moving. They are not moving on the right side. Rather, they are just vibrating to and fro. And suppose you are here, the ears are here, want to listen the sound. Now, what happens here, how the sound travels? Firstly, the first layer of the molecules will start vibrating, and gradually they will give the energy to the second layer such that the second layer starts vibrating. Second layer will further give the energy to third layer such that third layer starts vibrating. Similarly, fourth and then fifth layer will start vibrating. And the fifth layer will vibrate and produce the vibration in your ear diaphragm, and that vibration of ear diaphragm will be sensed as sound by your brain. Now you can see first ray vibrating, then second, then the waves continue to vibrate third, fourth, fifth, and after fifth, the sound is produced in your eardrum. So this happens. So in this case, the air molecules are vibrating. What is happening? Sound is being transported in the air without the transportation of air molecule. The molecules are not transferring. Rather, molecules are allowing the energy to transfer. This is not the case that first layer is traveling further. Rather, this is not happening. What is happening here? The air molecules are vibrating to and fro. Energy is being transferred. So sound is traveled through a certain medium. These particles are basically the particles of the medium. And children, that medium can be air. Sound can travel through air, water, metal, even human bone. Sound can travel through human bone also. So now, there are certain materials which can absorb sound. Such materials are known as sound absorbing materials. Most of the sound incident on blanket, thick curtains, wooden furniture, etc. is absorbed by sound absorbing materials as they transmit or reflect only a small fraction of incident sound. Children, light does not require any material medium for its propagation, and thus light can propagate through vacuum as well. Children, today we will study a new topic, that is transverse waves. Now, what are transverse waves? These are the waves in which particles of medium vibrate about their mean positions in a direction of propagation of the wave. These are the waves in which particles of medium vibrate in perpendicular direction. For example, if the wave is propagating in a horizontal direction, suppose the wave is moving along x direction, positive x-axis, then the material medium will vibrate in upward downward position, that is vertical direction. So what happens in transverse waves? In transverse wave, the direction of propagation of medium is perpendicular to the direction of wave motion. So students, for understanding transverse wave, see what happens in case of transverse wave. The material medium is propagating along vertical direction while the wave is flowing along horizontal direction. Wave is moving along horizontal direction, but the particles are vibrating up and down. See, when I started the vibration, it started with my hand. The material is oscillating up and down, but the wave is continuing to move in a forward direction. See what is happening here. So the direction is wave is moving along horizontal direction, material is vibrating along vertical direction. See, now further you can have a look. These are the particle medium. And let us see what happens in a particle medium. The direction of wave propagation, horizontal, particle vibrating up and down, vertical. This is transverse wave. So students, such waves can only be produced in solids and on the surfaces of liquids. They cannot be produced inside the liquids. Transverse wave can be produced, it can be produced at the surface of liquids, but cannot be produced inside the liquids and even in gases. Children, transverse waves travels in form of crest and troughs. So if we are having material medium which is vibrating along vertical direction, the upper half of the wave is known as crest, while the lower half will be termed as trough. Children, when the particles were at rest, that position is known as mean position, while when the particles started vibrating, the position of maximum upward displacement with respect to the mean position. If you compare the mean position and if I talk about maximum displacement in an upward direction, then it is known as crest, while the position of maximum downward displacement of the vibrating particle with respect to its mean position will be termed as trough. So, what is crest? The position of maximum upward displacement with respect to mean position, while trough is the position of maximum downward displacement with respect to mean position. Now coming to further terms related to wave motion, first is amplitude. Children, the maximum displacement from the mean position. The maximum displacement from the mean position is known as amplitude. So this dotted line is telling you about amplitude. Suppose its value is 3 meter here, then your amplitude is 3 meter. It is denoted by symbol small a and its SI unit is meter while CGS unit is centimeter. Coming to the second term, that is time period. Time period is defined as time taken by a particle of medium to complete its one vibration, and it is denoted by capital T. Its SI and CGS units is seconds. Children, kindly observe figure number 2. In figure number 2, I have drawn a wave having amplitude 5 meter, and children, I have drawn 2 waves here. One I have shown with blue color while the other I have shown with a green color. one wave is made up of one crest and one trough. So children, I have denoted C1 for crest 1, T1 for trough 1, C2 for crest 2, and T2 for trough 2. Children, the time taken for the first wave, only the first wave, the time taken for the first wave to complete is known as time period. So how many seconds here? See, one crest and one trough is completed in a time interval of how much? 8 seconds. So here the time period of the wave is 8 seconds. Don't write it as 16 seconds. In 16 seconds, there are 2 waves. So time taken is 8 seconds. Next is frequency. The number of vibrations made by a particle of medium in 1 second is known as frequency. It is usually denoted by F, N, or there is a special symbol here. We can say it is italic V, and the name of the symbol is nu. How to write? Just you have to make 2 curves, and these 2 curves have to meet at a point. So this name of the symbol is nu, and it is used to represent frequency. Children, mathematically, frequency is reciprocal of time period, and SI unit of frequency can be said as second inverse, which is most commonly known as hertz. And to write hertz, we will write capital H with a small z. Your Z should not be capital. Z should be written in small letter. Children, frequency is the characteristic property of source, and thus it is independent of amplitude of vibration and nature of medium in which the sound wave propagates. Frequency does not depend upon amplitude of vibration and even the nature of the medium in which the sound wave propagates. Children, in this figure number 2, if I want to find frequency, frequency means number of vibrations in a second. Even the formula of frequency was 1 upon time period. Since time period is 8 seconds, so I'll write down 1 upon 8. Children, the answers of numericals in physics are not to be kept in fractions. Rather, you have to find the answers in decimals and, if possible, up to 3 decimal places. So 1 by 8 can be written as 0.125 hertz. Children, then see figure number 3. There is a graph between displacement and distance. Again here, I have shown you 2 waves. One a little bolder and the second one is thinner. Here you can see crest and trough making one wave, and then you are having further another wave where we are having one more crest and trough. Children, right now we will learn about wavelength. What is wavelength? Wavelength is the distance traveled by wave in one time period. Time period was 8 seconds earlier. So how much distance is traveled by a wave in one time period is known as wavelength. There can be one more statement. We can say that wavelength is distance between two consecutive troughs and two consecutive crests. So the distance between two consecutive crests and the distance between two consecutive troughs is known as wavelength. The symbol of wavelength is shown in the PDF also, and the name of the symbol is lambda. Lambda here represents wavelength. In both the cases, whether you take distance between the two crests or the distance between two consecutive troughs, both the cases, your wavelength will come same. Children, the word consecutive is very important to be written in this definition. So with this, I come to an end of this interactive session. Children, kindly go through the PDF and learn all the new terms, especially regarding transverse waves and requests of the medium for the wave propagation. Thank you, students, and have a nice day.